Oh, it is good. Okay, so composite. They ripped it out. Okay, good times. So, can you get the light, please? Okay. Composite functions are functions that are formed from two functions, f of x and g of x, in which the output of one function is used in the input of the other. So you're literally going to take, say, f of g, and you're going to insert it, or f of x, sorry, and you're going to insert it into g, like into the g equation. So what we've done before is if I asked you for f of 3, you knew what? What does f of 3 mean for any equation? If I gave you f of 3 in brackets. Put 3 in for every x. So what if I gave you f of y? What would you do? Put y in for every x. So what if I gave you f of g of x? You'd put g of x in for every x. That's it. That's what that means. So f of g of x is read as f of g of x. So we take this g of x and we put it in for every x in f. That's it. And if it was g of f of x, we put f of x in for every x in g. That's it. Okay? If you think of it in the simplest form where it's like f of 3, I put 3 in for every x, or f of y, I put y in for every x in f. F of g of x, I put g of x in for every x of f. It's the same thing. Okay? If they write it like this, do you see now here's the open dot? The open dot means composition. Remember how I said closed dot means multiplication, but an open dot's going to be different, but you're going to learn that? Here you're learning it. So if you have it like that, it's not hard. Rewrite it in this form. You just rewrite it in the same order. So if this is f open dot of g, that's just f of g of x. If I gave you h open dot of f, let's say, that's the same as saying f of x. H of f of x. I don't know why I said f. H of f of x. So you just write them in the order. Okay, so that's a good thing. It's not like they're backwards or something. So, for example, if f of x equals 2x minus 2 and g of x equals x squared plus 3x, then f of g of x equals this little x in f here. I'm going to take that x, I'm going to huck it behind my head. I'm going to take this and I'm going to throw it in its spot, right? So instead of having an x there, the x gets thrown out and I replace it with g, which is x squared plus 3x. And the rest stays the same, right? The 2 and the minus 2 stayed the same. I'm just taking g and I'm replacing it for every x, correct? So not too bad. So the output for g of x is the input for f of x. The output for g of x is the input for f of x. So what that means is if I did give you, for example, this example up here, if instead of f of g of x, if I gave you f of g of 2, what would you have to do first? Put 2 into the g, get an answer. Then put that into f. That's it. So this says the output for g of x is the input for f of x. That makes sense, right? The output for g of x, so for g of 2, would actually be what you're going to input into f. So what your answer is here, you input into f. Does that make sense? Okay. So we just find g of 2, plug it in, whatever that answer says, it's 11. Then we do f of 11, let's say. Okay? You would always distribute the 2 in. That was just proving a point. Yeah. You distribute and collect like terms. So to determine the equation of a composite function, substitute the second function into the first. So f of g of x. G of x is x squared plus 3. So we go f of x squared plus 3. Then we'd substitute that in for the x, right? And then we distribute. And if it was g of f of x, we'd take whatever f of x is. So we do g of 2x minus 1. And we plug that in for the x, right? So we get 2x minus 2 squared, because it's x squared, plus 3 times x, which is now 2x minus 2. Distribute, collect like terms. If you've noticed, f of g of x does not equal g of f of x, right? So remember, when I said addition, you could have them the wrong way around, it would still work, right? Multiplication, you could have them the wrong way around, it would still work. It wouldn't be correct math, but your answer would end up being luckily the same. But subtraction and division, it wouldn't be, correct? Composition as well. You have to put them in the order they are. So I would just always put them in the order they are, and it doesn't matter which form it is, right? But on a test, on a diploma, if they said f plus g of x equals g plus f of x, and then f minus g of x equals g minus f of x, and they asked you how many of the following statements were true, you'd need to know that, though, right? You need to know that the order of addition and multiplication doesn't matter, but division and subtraction and composition does matter. So you need to understand those rules, because what if they give you that as a question, right? Just asking your understanding. So sometimes it's just understanding questions on the diploma. It's not actual. That's why you have to understand it fully, not just memorize steps. Okay? So the domain of f of g of x is a set of the values in the domain for which g of x is the domain of f of x. Restrictions must be considered. So the catch on this is, say this was the function. Say you had f of x equaled x squared, let's say. Okay? And g of x was square root x minus 2. We agree? And say I asked you for f of g of x. So it would be f of g of x. G of x is x square root of x minus 2. We agree, right? So I'm inputting that into here. Now that means I'm going to put that in for the x. So I get square root x minus 2 squared, right? The square root goes away, and I'm left with x minus 2. What's the domain of x minus 2? It's just a line, so it's just xer, right? However, you did have a square root before, did you not? And if at any point in time you have a restriction, do you not have to state it? Yes. So what happens is people will say xer, and that'll be the answer on the diploma, and you're wrong. Because back here, x had to be greater than or equal to 2, did it not? So does it there. Okay? So if you just put into your graph this, so go into your calculator and type in x minus 2. In your y1. You're going to get a line, right? Slope 1 over 1, y-intercept negative 2, positive direction, xer, right? Now, into your y2, type in this question before you actually canceled it, because this equation is the same as this one, agreed? This is just the simplified form of it. So type in to your y2, square root x minus 2 in brackets, squared. What do you get? Where does your graph only start at? 2 and higher, right? So if you made it thicker, if you make it the same thickness, you're not going to see anything. You're going to see a straight line. If you make it thicker or a different color, you'll see that it starts only at 2 and goes, right? So if you only give the domain of the simplified version, you have to watch yourself, because it'll be there, but it's wrong. Because this, you saw, when you put this into your calculator, it gave you a different domain. So if you're ever just asked for a domain of a composite function, once I fill in my composite function, I would just put that into my y equals and look at that domain. I wouldn't look at the actual reduced domain, the nicely distributed and collected terms. I would look at the instant I plugged it in, I would put that into my calculator and look at that one, because that's going to cover all of your restrictions, right? So if I was just asked for the domain or the range, I would put in that. I wouldn't even simplify it. I'd literally just put in the filled-in version, the distributed inversion substitution. Okay? If you're asked for the actual equation, you keep going. All right. So use the graphs of f and g to evaluate the function. We'll do the first one, you'll do the next 3. So we have to find g of 6 first. You guys told me that, right? So we go to our graph, and we go to where g is 6. So we go to 6, and we follow it up to g, which is what? 3. So now I actually have f of 3. My output of g is my input of f, right? And now I go to 3 and follow it to f, and what is it? 0, and that's my answer. You try the next three. F of 7 is 2. Then we need to find G of 2, which is 5. Yeah? So what's the difference between example 1 and example 2? Now you have to actually figure out the point. Here you could just go look at it, but still not hard. So off to the side, I'm going to do G of negative 4. G of negative 4 is negative 3 times negative 4 plus 5. So it's 12 plus 5, which is 17. So this is 17. So instead of going to my graph and pulling it off the graph, I'm literally just finding G of negative 4, right? And now I can replace G of negative 4 with 17 because that's its output and it's the input of F now. So I'm going to find F of 17. So F of 17 equals 17 plus 6. So it is 23. Yeah? Ooh, that was close. Ugh. So I took my computer onto the ground. That would have been really bad. Okay. F of 0 equals 0 plus 6. So it's 6. So now instead of F of 0, I have 6. So G of 6 equals negative 3 times 6 plus 5, which is negative 18 plus 5, which is negative 13. Bless you. And then if they're the same, it doesn't change it, right? You're going to do G of 8. So I'm going to do G of 8 first. So I'm going to get negative 3 times 8 plus 5, which is negative 24 plus 5, which is negative 19. Bless you. So now instead of G of 8, I can fill in 19, right? Because that's the answer to it. And then we're going to do G of negative 19, which is negative 3 times negative 19 plus 5, which is 57 plus 5. Okay? Flip over. I know it's going to hurt you to leave D, but if you want to do it, you can. I'm going to flip over to the next one. Okay, so here we have f of g of x and g of f of x. So this is that example where I told you if you square a square root, the square root will go away, but you still need to remember the restriction of the domain. Okay? So this is f of g of x, because we always just write it in the order. So we're actually finding f of x squared. We just fill in g of x, correct? Now for every x in f, I'm going to replace that x with an x squared, right? That's all this means. So I'm going to have square root of something plus 4, because it used to be x, but it's not going to be x anymore. I'm going to replace that x with a x squared. That's as good as it gets. Now, if I actually ask you for the domain of that one, because that's going to be your domain, right? You can look at it. The domain of that one is XER. Why? Is it going to be XER? What's it going to be? Yeah. It'll always be positive or at least not 0 because whenever you fill anything for that x, it's going to cause it to be positive. Yeah. X squared plus 4 is an addition of squares. An addition of squares you can do nothing with. A difference of squares, so x squared minus 4, you could factor to x minus 2, x plus 2. You still couldn't take anything out, but you could sit there with 2 factors underneath the radical. But you couldn't take either of them out, right? X squared plus 4 you can't factor. Because actually factoring means if you took those factors and you solved them out, those would be your x-intercept, correct? X squared plus 4 has a vertex at 0 and 4 and it's concave up. So does a vertex at 0 and 4 and it's concave up, does it have any x-intercept? No. This actually has no solutions, x squared plus 4. There's no place where it equals 0. So you can't factor it. Can't break it down. So it would be x here. So we have g of f of x. So it's going to be g of square root x plus 4. And then in for g, which is x, we're going to put in square root x plus 4. And we're going to square it. And before I square it, I instantly start writing my restriction for it. Now, why did I only have to write my restriction for this one after I substituted it in? Yeah. So the g of x that I was distributing in didn't have a restriction, right? So what I distributed in didn't have a restriction. What I was distributing into did. Here, what I'm distributing in has a restriction. So I have to deal with the restriction before I deal with the question. So here, my restriction is going to be x has to be greater than or equal to negative 4. Then these cancel, and my answer is x plus 4. So if I went to go draw the graph of this, I'd draw the equation x plus 4, but I would only start it when x equaled negative 4. So you could draw the whole line and just erase it after negative 4. Okay? F of g of x. So we're going to do f of 3 minus x. So we have to fill 3 minus x into the x of the absolute value. So we're going to get 3 minus x minus 4. So it's actually negative x minus 1 in the absolute value when you collect like terms. You could put brackets around it, but it's not going to affect it either way. You have to put brackets if there's a negative 1 in front. So had it been 4 minus x, then you would have to have brackets because you'd have to make sure you distributed the negative in. Yeah. So try the g of f of x and then try c. So this one's going to be g of f of x. So g of absolute value x minus 4 equals 3 minus the absolute value of x minus 4. And this one's going to be f of g of x. So f of x plus 3. So it's going to be 1 over x plus 3. And then you're going to get a totally different domain and range, right, than the normal x plus 3. So adding and subtracting, multiplying and dividing, product quotient, and adding and subtracting, it's the combined domain where they both exist that you would use. But with these, it's different. You have to actually watch them. So I always just plug in right away, right? So I can't simplify this anymore. But if I could, I would still plug this in right away to look at my domain range. This one's g of f of x. You would if I asked you for them. So the restrictions and MPVs would be for your domain and range. So this would be x can't equal negative 3, y can't equal 0, because the numerator is smaller than the denominator. So your horizontal asymptote is going to be at y equals 0, and your vertical is going to be at x can't equal negative 3 for your domain and range. So this one would be x can't equal 0 and y can't equal 3. because it's in that other form, right? This would be your vertical translation, which changes your asymptote. All right. So difference in the two. Depends on what form they want. So if it's a multiple choice or a numeric response, you would depend on what form they want. So if they wanted it all together, you would multiply by x over x and put them together. Yeah. Yeah. I was just going to show it to you after, not on the test, because it's like an extra step at which I'm not going to ask you on the test, but I want to show it to you before the diploma. But I don't want it to throw you off for the test. So for f of x equals x squared minus 2 and g of x equals 4x plus 1, sketch the graphs of the composition function. So you'd have y equals f of 4x plus 1. And so y equals 4x plus 1 squared minus 2. And that would get you 16x squared plus 8x plus 1 minus 2. So y equals 16x squared plus 8x minus 1. And then you just graph it, right? Give the domain and range. So you're going to have a minimum at negative 0.25 and negative 2. So negative a quarter. Negative 2. And negative 1 and 7. 0 and negative 1. So it's going to be something like, ooh, this is really bad, like that. Pretend that's a better parabola. That's really wonky. So your domain would be XER, or negative infinity, positive infinity. And your range would be y such that y is greater than or equal to negative 2. So like I said, if you want an accurate domain and range, always plug in before you simplify. And if you want to just graph this, you could plug this bracket 4x plus 2 squared minus 2 in your calculator, right? You wouldn't have to simplify it. Shh. All right. Flip over. So we'll do this one here. This is one of those where I give you h of x and I give you f of x and make you find g of x. You remember those weird ones? These ones are the ones where you have to actually look and think, hey, what would I have to do? So h of x equals f of g of x. Now, when we did it as product and quotient and adding and subtracting, we could just solve. We could just fill in and solve, right? Not the same with composition, because you can't like undo a composition, okay? So you're going to have to look at what you have. So h of x is 1 over x minus 2 squared. We agree? And then g of x we don't know. So we're going to leave it as g of x. So we're going to plug g of x in for the x's in f, right? So we're going to get 1 over g of x squared. We agree? So what would g of x have to be in order for this to be true? X minus 2. That's it. Right? So we're not doing any real like operations or anything to it. We're just comparing them. So this one's a little different because they gave us f of x. So we have h of x equals f of g of x. So h of x, oh, they gave us f again. Square root x squared minus 2. We don't know g, so we're going to go square root of g of x. Because we're plugging g of x in for all the x's. So what would g of x have to be? X squared minus 2. Okay? This one we did earlier where we covered it. You just have to remember that whenever you're inserting a square root in, actually we'll do it again because this is the one that people get messed up. So say we have f of g of x here. G of x is 3x plus 1. So we're putting that into the radical, correct? So it's going to be square root. 3x plus 1 is going in for x. 3x plus 1 minus 4. So you could put it in right at that point and look at the domain, right? Or I'm going to simplify it. Square root 3x minus 3. So this one's different than the g of f of x because I'm taking this and I'm inputting it into the radical, correct? So now I'd have to find out 3x minus 3. When it's linear, you can just set greater than or equal to 0 and solve it, right? If it's quadratic, you'd have to actually look at where it's greater than or equal to 0 and get the x-intercept. So we'd have 3x is greater than or equal to 3, so x has to be greater than or equal to 1. How could I get the range then? You could plug 1 in and see what you get, right? Because it's going to be a point. It's going to be at 1 in something. You plug a 1 in here and you're going to get 0. Now, is there a reflection so that it's less than 0? Because there have to be a reflection in the x-axis. Is there a reflection in the x-axis? No. So it's going to be y is greater than or equal to 0. Remember your rules, right? And this one here, you know that it's 1 because when you take that 3 out, it's a horizontal stretch, but that's not going to affect your original point, right? Your original point on a radical is at 0, 0. And the only thing that moves that radical is a vertical translation or horizontal translation that moves that very initial point. Because if I multiply 0, 0 by anything, it's going to stay 0, 0, right? So remember with radicals, the only thing that moves and changes your domain and range are horizontal and vertical translations. Reflections can make your domain and range change the inequality sign. This g of f of x, now I'm actually inputting a radical. I'm going to get 3 times square root x minus 4 plus 1. So my domain is going to be x such that x is greater than or equal to 4 xer. It's greater than or equal to because there's no negative in front of here. So it's not making it reflect in the y-axis, right? So it's going to be greater than. And it's 4 because we have a horizontal translation 4 to the right. Okay. Now we have a vertical translation 1 up. So we know it's going to be greater than or less than 1. Which one is it going to be? Greater because I don't have a reflection in the x-axis, right? So my range is y such that y is greater than or equal to 1. So other functions, the actual part of the other functions and the solving of the other functions and the composition and stuff like that isn't the hard part. It's remembering the rules about all the rest of your functions. That's the hard part. Remembering what moves them for the domain and range, right? Rationals and radicals, and they can put polynomials in here. They could put logs or trig or anything in there. So it's not the actual lessons themselves that are difficult. It's using all of the knowledge you have in your head from all the different functions into the composition that makes it difficult. And the next page, I think, is your homework. That's just more practice questions. You don't need. Oh, this one. So if it's like this, I forgot to go over this one. This one's f of g of h. So this would be f of g of h of negative 8. Now close a bracket for that one, close a bracket for that one, close a bracket for that one. This looks a lot more difficult than it really is. We're just going to find the output for h of negative 8, put it into g. On the output of that, put it into F. So you're just doing it 3 times instead of 2. It's not crazy difficult. So I'm going to go off to the side. I'm going to do h of negative 8. I forgot my marker doesn't change. So we get absolute value of negative 8 plus 2, which is the absolute value of negative 6. What's the absolute value of negative 6? 6. So now instead of this, I have a 6. So now I have f of g of 6. So now down here, I'm going to find g of 6, which is 3 times 6 plus 2, which is 18 plus 2, which is 20. Now instead of g of 6, I have 20. So I'm finding f of 20, which is 20 squared minus 1, which is 400 minus 1, which is 399. And if it wasn't numbers and it was actual like equations, then you would just literally take the h equation, plug it into the g for all the x's, reduce it. Take that equation, plug it into the x's f, reduce it, right? It's just the same thing. That's your homework.